Welcome to this lesson on levers and gears. We're starting with the question, why do bikes have gears? So what I'd like you to do is pause for a moment and consider your answers to that question. Okay, so the reason that bikes have gears is to make it easier to cycle. It means that you have to apply less force to have the same effect. Okay, so it's reducing the amount of effort that has to be put in. Levers and gears are both used to transmit the rotational effects of forces. Okay, so if we think about where the best place is to turn a spanner, we turn it from the very end. And the reason for that is because that gives us the greatest moment. Remember, the moment is equal to the force times the distance. So the bigger the moment, the bigger the turning effect of the force, and therefore it enables us to emit a larger force. Okay, levers are objects that are used to change smaller forces into larger ones. So we have a couple of examples here. A man lifting a stone using a lever and a pair of pliers. In both cases, we apply our force further away from the pivot than we want the effort to be made. Okay, the lever works by reducing the amount of force needed to move an object or lift a load. A lever does this by increasing the distance through which the force acts, and the closer the pivot is to the load, the less effort is needed to lift the load. Okay, so we call the weight of the object that we're trying to move the load. The force that's applied is called the effort, and the point at which the lever turns is called the pivot. In some diagrams you'll see it as the fulcrum. That's the American way of saying it. We use pivot. And a lever is an example, as we keep saying, of a force multiplier because they can be used to increase the force acting on an object, making it turn more easily. Now what I'd like you to do in each of these cases is label the pivot and where the force is applied. Pause the video for a moment while you have a go at that. Okay, we're going to start by looking at the tap. And for the tap, the pivot is right in the center of the tap. And the force is going to be applied in a clockwise manner in this case. Okay, turning this spanner, the pivot is at the center of the nut, and the force is going to be applied from the handle downwards. For the wheelbarrow, the pivot is at the center of the wheel, and we're going to be lifting that one by the handle. For the claw hammer, the pivot is where the hammer meets the surface, and the force is going to be from the handle. And then for our door handle, the pivot is at the center again where it rotates, and we're going to have our force acting downwards. Okay, so some more examples of force multipliers. A bottle opener. So the force on the cap is bigger than the force that's applied because the line of action of the force you apply is further away from the pivot than the edge of the cap is. Similarly, scissors. If they've got sharp edges, they cut easily, but that's not just because the edges are sharp. The force on the scissors that we create is smaller than the force that's being applied by the blade because we apply our force further away from the pivot than the object we're cutting. Okay? If a nut on a car wheel is difficult to undo with a short spanner, we use a longer spanner. Why? Because we're increasing the moment. Remember, the moment is equal to the force times the distance from the pivot. If we've got a longer distance, we're going to create a much larger moment. Then that is going to be equal to the moment in the other direction, which has a shorter distance, therefore creating a bigger force. Okay, gears. Gears are wheels with teeth on them that slot together, and if one gear is turned, the other gear will be turned as well. If the gears are of different sizes, they can be used to increase the power of the turning force. The smaller wheel in a combination will turn more quickly but with less force, while the bigger one will turn more slowly but with more force. Okay, so that's some gears in action. Quick tip, gears in line change direction with each gear wheel. So you see that one goes clockwise, then the next one goes anti-clockwise, and so on. If you're faced with a question like that, draw in the directional arrows for each cog. It will make your life easier. Gears are like levers because they can multiply the effect of a turning force. If a wheel has more teeth, and remember the teeth on each wheel have to be the same size to interlock, a wheel with more teeth will turn slower. The bigger wheel is turning at half the speed of the smaller wheel in this case, but the moment of the turning force will be twice as big. How about here? Well, in this case, the bigger wheel is turning at a third of the speed of the smaller wheel, but the moment is 3 times that of the smaller wheel. Okay, so when we're in low gear, a small gear wheel is used to turn a large gear wheel. The output shaft therefore turns slower than the engine shaft. The turning effect of the output shaft is therefore larger than that of the engine shaft. In high gear, a large gear wheel is used to turn a small gear wheel, and the output shaft turns faster than the engine shaft. And again, the turning effect is smaller this time than the engine shaft. Right, here's a couple of questions asking you to calculate some moments and their directions. So I'd like you to pause the video for a moment and work out the moments and directions on each of the 2 gears in this case. Okay, so for part A, you should have done 80 times 0.01, which is 0.8 anti-clockwise, and for part B, 80 times 0.02 is 1.6 Newton meters clockwise. Okay, have a go at these 2 past paper questions. Pause the video for a moment, we'll go through the answers in a second. Okay, so for question 1, AI, you should have done 300 times 1.2, which gives you 360. And the second mark is for the units of Newton meters, or Nm, capital N, little m. 3 points for part B. The force is further from the pivot. That caused an increased moment to act on the bar, and therefore an increased force act on the tree stump. Then for question 2, for part A, the centre of mass is where the mass of the object can be thought to be or can be considered to be concentrated. You don't get the mark if you said where it is concentrated, remember. Part B, first mark is for saying something about making the centre of mass lower down, and the second mark is for saying making the base wider. If you've described anything that could do that, you'll get the marks. Then for part C, the first mark is for saying the line of action of the weight, or a vertical line from X. The second mark is for saying falls between the wheels, or falls inside what we call the wheelbase. And the final mark is for saying there is no resultant or no clockwise moment. Okay, have a go at the work on fronter, and I'll see you next time.